in this video, we are going to look at a reference angle. So, what does it mean by a reference angle? Let's assume that an angle theta is in a standard what position. Its reference angle is the acute angle theta formed by the terminal side. So we are saying that its reference angle is the acute angle theta formed by the terminal side of alpha and the s-axis. I'll explain all this to you in the diagram. It is positive acute what? Angle. Alright, so here let's look at the first quadrant. Sorry, the second quadrant. Now, in the second quadrant, a reference angle can only be formed in a second quadrant, third quadrant, and the fourth quadrant. So, in the second quadrant, this is the position angle theta that we have here, the standard position angle theta. So, in the reference angle, in the second quadrant, the reference angle will form here. If you are in the second quadrant, your reference angle will form here. And the angle always makes with the what? The s-axis, the triangle. Or the right angle triangle always makes with the what? Or the angle always makes with the what? The right, the s-axis. It will not form here, it will rather form here. So that is what we mean by that. So the alpha here is what you are saying is a reference what? Angle. The alpha there is what is representing the reference angle. Alright. Sorry. Make here. Let's here be theta. And let's it be alpha rather. Okay, so H reference angle is the acute angle alpha. Yes. So the alpha here is representing the acute angle. And when you are in the third quadrant, oh, there is a mistake here. When you are in the third quadrant, that means that when you are here, it forms up to here. Alright? And your reference angle always makes with the s-axis. So your reference angle alpha will form here. From here to here. I hope it's clear. Alright. And when you are in the fourth quadrant, your reference angle will form here, and that's that. Alright, so let's look at some examples. Find the reference angle of the following. Find the reference angle of the following. Find the reference angle of the following. One, 250, 2, 120 degrees, 3, 1387 degrees. Alright, so let's see how we are going to find the reference angle. Now, in finding the reference angle, sometimes it's good for you to sketch it so that you understand it well. Alright. So 250, let's sketch 250. And just assumption that we are going to do. Where do you think, which quadrant do you think 250 will be? Here is 0 degrees, here is 90 degrees, here is 180 degrees, here is 270 degrees, here is 360 degrees. You know that 0 degrees and 360, they are coterminal angles, so they are on the same side, terminal side. Alright, so what do you think, where do you think 250 will be? 250 cannot fall in the second quadrant, it will rather fall in the what? The third quadrant. So just trade it anywhere. Alright, so that means that from this to that is theta, which is 250 degrees. So to get the reference angle, to get the reference angle. The reference angle 2 will be forming here. That will be forming here. So that will be from here to here. Alright. So what we think a reference angle will be? We know that from here to here is 250. But we are looking from here to here. Okay. We also know that angle on a straight line is equal to 180. That means from here to here is equal to 180. So if from here to here is 180 and from here to here is 250, then to get from here to here, we need to subtract 180 from the 250. So the reference angle alpha is just going to be equal to the 250 minus what? The 180. And that is 70 degrees. So that is why we are saying that. Alright, so that is that. So that is what? 70 degrees. So the reference angle for this is going to be 70 degrees. I would like you to try on the rest. Okay. Try on the second one, okay? Try on the second one and give me the reference angle. Let me help you on the third one. The third one. You see, the third one is too huge, alright? So you just subtract 1387. It's not easy. 1387. Now, let's see. With 1387, you have to go about more than 2 or 3 revolutions, because one revolution gives what? 360. Another one, 360. Another one, 360. So you can see that 360 3 times. 1, 2, and 3. So multiply 3 times 360. Then you get 1,180. And it's still not up to this number. Alright? So what we do is that, then let's go again. Let's multiply 360 by 4 and see. Oh, 360 times 4 is 1440, which is more than what we have here. That means that what we are looking for will just be in this. What we are looking for will just be in the 360 times what? So we have to, the alpha will be equal to 1,387 minus 3 times 3, 360. Because we know that when we multiply 4 by 360, we get a huge number, which is more than what we have here. So when you subtract this from this, let's see what you're going to get. 1,387 minus 3 times 360. We get 307. 307 degrees. Alright. So now, this 3707 is going to be coterminal. It's going to be coterminal. And I hope you understand coterminal. This 308 is going, this 307 is going to be coterminal to 1,387. Because we are saying that a coterminal angle, they have the same initial and terminal side. So this and this, they are going to be coterminal. So if you are looking for the reference angle for this, it's the same as you looking for the reference angle for this. So if it's the same thing, then we go and do that. That is the reference angle for this. And looking at this, we know this is going to be in the 4th quadrant. So from here to here is the 307, that is theta. Alright? That is going to go at theta. So let's look for the reference angle for this. We know that the angle also makes with the what? The x-axis. It makes with the x-axis. So we are looking for this what angle. So if from here to here is 308, and we are looking for what is here. But bear in mind that from here to here is what? 360. So if we pick 360 and subtract 307 from it, whatever we are going to get is going to be the reference angle, and that is 53 degrees. Alright? So 53 degrees is going to be the reference angle. It's going to be the reference angle. Very good, very good, very good, very good. Alright. So let's see. Let's look at special angles as reference angle. Special angles as reference angle. I hope I can feel it. Alright, we have established these things already, okay? For instance, if you are to find the value of the trigonometric functions for 210, example, find the value of the trigonometric functions. And hope you know all the trigonometric functions for 210 degrees. Alright, for 210 degrees. So the solution. So to find the value of the trigonometric function, that is sine, cos, tan, and their reciprocals. We know with this you need to sketch, alright? Then we are going to look for the reference angle. So 210 will be in the third quadrant. Because here is 180, so 272, 210 will be in the third quadrant. So from here to here. So the reference angle mixed with the x-axis. So if theta is equal to 210 degrees, what do you think the reference angle will be? The reference angle alpha will be equal to, that is, when you subtract 180 from what? The 210. And 210 minus 180 is just going to be it's just going to be 30 degrees. So we get 30 degrees here. So what we have here is going to be 30 degrees. So now, this 30 degrees being our reference angle, don't forget that we have already found those values already. So here is 30 degrees. Alright. And if you have that to be 30 degrees, here is going to be 90, here is going to be 60. That's what you're going to get, alright? And the other side will be the what? The radius. And the other side will be the what? The radius. This side. Okay. Now, using the idea of 30 degrees to 60 degrees right triangle, alright, we know that the R will be equal to what? 2. The R will be equal to 2. The R will be equal to 2. And the S will be equal to square root of 3. And our Y will be also be equal to negative 1. Our Y here is going to be negative 1. Alright. Don't forget that the first one that we draw in the previous video, for that one, there was nothing like a quadrant at that time. So we were having a 30 degrees as our reference angle without any quadrant. So we said that here will be 2, here will be 1, then here will be square root of what? 3. Yeah, something like, yeah, square root of 3. So now that we have this in a quadrant, I hope you are with me. Note that on your xy plane, on your graph, the x values here is going to be negative, the y values here. So now instead of the 1, so now instead of the 1 representing x, it's now going to be negative 1 because the x values here is what? Negative. And the y will also be negative because we are in the third quadrant. Negative square root of what? 3. So that is what you are going to get. So you go for sine 210. Sine 210. So sine 210 is going to be what? You know that the reference angle is 30. Alright, so sine 210. We just go for it. So sine is what? Opposite over the hypotenuse. So the opposite is what? Negative 1, and the hypotenuse is what? 2. Please, how will you can grab what I want to project to you? When you go for cos 210, cos 210 is also the adjacent over the what? Cos 210 is the adjacent over, the sine is negative square root of 3 over this, and this one will be negative 1 over 2. So look for the rest. Go for tan, sec, and the others. Alright. Oh, sorry, let's correct this mistake. Now, when we're having when we're having the 30 degrees to be our reference angle, the square root of 3 is the x, and this is rather 1. Alright? So when we project this in the third quadrant, the x value here is going to be negative square root of 3. Then, I hope we are not confused. Then we get this to be negative 1, because on the third quadrant, the x and the y and the x is what? Negative. Okay, on your graph, negative values. So that is what you are going to get for that. So for sine 210, we are going to get opposite, negative 1 over the hypotenuse. And this is negative square root of 3 over the hypotenuse, which is 2. Alright, good. So look for the rest. Sorry for that. Look for the rest. Because we are having here to 30 and here to what? 60. Okay. Very good. Alright. So you can go for the rest. We can get tan. Tan theta would be what? Y over x. So negative 1 over negative square root of 3. So we get 1 over square root of 3. Then you go for sec. Sec theta will be, so the theta is 210. 210. Alright. And with that one we get sec is reciprocal for what? For cos. So 2 negative square root of 3. Go for the rest and then try on this one. Find the exact value of each expression. Find the exact value for each expression. A cos negative 240 degrees, B tan. Alright, so let me assist you with your try work. The first one. Let me assist you on the first one. We have negative 240. We know that cos negative 240, we know that negative angles read from this side, okay? We have the anti-clockwise or counterclockwise. And this what? Clockwise. So we read from the clockwise. So you can see that negative 240 will be somewhere, if here is 0 degrees, 90 degrees, 180 degrees, then negative 240 will be somewhere here, because from here will be 270 degrees and 360. So it will be somewhere here. Alright, I'm going to get that to be somewhere here. So this will be the theta, which is negative 240. And the reference angle is just going to be the reference angle, which is alpha. The alpha is just going to be 3. We know that from here, we know that from here to here is 180. Alright, so 240 minus 180. 240 minus 180. That is 60 degrees. So we are going to get 60 degrees. So this reference angle to the x is going to be 60 degrees. So therefore we go for the one. In fact, you can just use only one diagram, okay? This is the 30 degrees. So the 60 degrees, if you want the 60 degrees to be your reference angle, you turn it this way, okay? So it's going to be like this. Hope you can see that. Alright. So here, you are going to have the 60 degrees here, the 30 degrees here. So this is your what? Your reference angle. This is your reference angle. So therefore, this now is the opposite. So here will be the square root of 3. The adjacent now will be 1. Hope you can see that. And the radius is 2. So here we can get 1 here, but here you know that you get negative, because on your xy plane, alright, here is negative values, and for the y here is positive values. So here you get square root of 3. Okay, very good. And here will be 2. So to get cos negative 240 is just cos is adjacent over the hypotenuse. So you get negative half. Let me tell you one thing. Even if you don't know that here is, I hope this one is clear. But even if you don't know that here is negative, alright? And after knowing that this is going to give you half, then you ask yourself, in the second quadrant, sine is only positive. That means that cos is negative. And that is how you are going to use to solve such question. So you try on the tan 675 and see what you are going to get. Alright. Alright. Let's look at the last part in this video. Solving right angle triangle. Okay. So to solve a triangle, means to find all the measure of all the angles and sides of the what? The triangle. So you know that the side for this is A, B, and what? The C. Okay, and we have the angle of this, and this angle we can represent by what? Theta. Can represent this by theta, and this one too by what? Alpha, and all that. Good. You also know that when we sum the interior angle of what? A right angle triangle, you get what? 180. Okay. You know what A stands for, what B stands for, what C stands for already. So let's solve this question. Solve right triangle. Solve right triangle. ABC. If A is equal to that is 34 degrees 30 minutes, and C is equal to 12.7 inch, like centimeters and all that is a unit. Okay, but please here, you know that solve a right angle triangle, okay? ABC, so we need to draw a right angle triangle. You can name it anyhow you like, A, B, C. Alright? And it says that if A is 34 degrees 30 minutes, C is equal to this. So we have been given an angle of what? A. That means that we have to represent our diagram well. You cannot, we know that this is 90 degrees, okay? So we can make it this way. A, B, C, alright? So that this will represent the what? The angle. But NB, note that this 34 degrees 30 minutes can be converted, alright? That can be converted. So, how do we convert that? We know that the 34, the problem is not on the 34. The 34 is already in degrees. So, 34 in degrees already. Okay. Then, this 30 minutes, to change it, you divide by what? 60. Alright, you divide by 60. And when you divide, okay. And when you divide that by 60, you get half. So with this, you get half. You get half. Alright, you're going to get half. And the half, let me give to you 30 minutes is equal to 30 over 60 is equal to half. Alright, which is the same as 0.5 degrees. So we now add up these two ones. This. But the angle here, we know that it is 34 degrees 30 minutes, alright? But therefore, 34 degrees 30 minutes is now going to be 34 plus 0.5. And what are we going to get for that? So we get 34 plus 0.5. And that's going to be 34.5. 34.5. 34.5. So we get 34.5 here. I hope you can see that. So we know this angle A is the same as 34.5 degrees. So we have the side C to be 12.7. And what again? That's all that we have. And we have to find all the side. Okay? We have to find all the side. So how do we do that? So let's represent here by A. Let's represent here by B. That is what we don't know and we are finding it. So SOHCAHTOA, which one is going to help us? We know that we are using SOHCAHTOA. SOHCAHTOA. Which of the formula will connect the adjacent and the angle? So you can see that the one that we can get as the adjacent in is this and this. So we can use tan theta, which is what? Opposite y over what? S. So here, tan 34.5 degrees is going to be equal to A over 12.7. This means that we are looking for what? A. The side A. So the side A is 12.7 times tan 34.5 degrees. And this is just going to give you 12.7 times tan 34.5. And Rachel in degree wood, and that is going to give you 8.73. 8.73. Therefore, the side A, the side, not this diagram. Therefore, the side A is approximately 8.7. Then we go for the side B. So the side B, since we have the opposite, then we can even use sine because we are looking for the hypotenuse. So we use whether sine or cos, the one that is embedded with what? Hypotenuse. So sine theta is equal to y over r. Therefore, sine 34.5 is equal to y is what? 8.7 over r, which is the b. So to get b is 8.7 over sine 34.5. So let's see what we are going to get. Answer over sine 34.5. And we are going to get 15.4. 15.4. Alright. And since in the question this is given in inch, where you get it in inch, so you get it in inch. I think you should add in place. So here to we get 15.4. I hope that is clear. Alright. Good. So that is that for that. We can even go for this angle. We can even go for this angle. Alright. And I know what you do to go for that angle. That is by turning it on this side. Okay. So we can turn that and go for the angle B. And how are we going to go for the angle B? Let's look for the angle B. Because we want to find all the sides and the angle. We know that here is what? 90 degrees. So interior angle is about 180. So we can even say 90 plus this is equal to 90 plus this is equal to 180, and we will get that. But we want to use the procedure, okay? So we have to redraw this. Now we turn it to this way. The B is going to be here. And if the B is going to be here, then we turn it like this. So here is going to be the C, which is the 90. Alright, and the top here will be A, and that is 34.5. So this is theta that we are looking for. And we know that the side of BC is 8.7. The side for AC is 12.7. And the side for 15.4. Alright, so to get this, then we can use sine theta is equal to y over or tan. We can even use tan. Any of it that you use, since you have all the sides, any of it will work. So tan theta is equal to y over what? S. So tan 45.34. Oh, the theta is what we are looking for. So this is our reference angle. So tan theta is going to be equal to y is what? 12.7. So the x axis here is now the y axis here. So 12.7 over 8.7. And you take theta to be equal to tan inverse of 12.7 over 8.7. And that is going to give you and that's going to give you 55. That's going to give you 55.587. 55.587. 55.587. So here is approximately 55. Theta is equal to 55.59. Alright. But here, don't forget that the angle here was given to us in degree and what? Minutes. So we can convert this one also to degree and minutes. Knowing that 55 is already in degrees. So the 0.59 is what we will what? Convert. And I have taught you how to convert already. So you can do that and go your way. So when you do that, you are going to get 55 degrees 30 minutes. 55 degrees 30 minutes. So that is what you are going to have for that. Because we know that 30 minutes is 0.5 degrees. Alright? And this is like this is like 0.5. This is like 55 plus 0.5. Okay? So that is what it's like. Therefore, that 0.5 is 30 minutes. So here we get 55 and 30 minutes. Therefore, the angle B is also 55 degrees 30 minutes. Alright, so that is that for that. Go and try it on your hands on this. Solve right triangle ABC. Solve right triangle ABC. Solve right triangle ABC. If small a is 29.43 degrees centimeters and C, no, there should be no degrees here, and C is equal to 53.58 centimeters. Alright, so you have two sides here. Okay, so you're going to use these two sides. One, you look for all the two angles. Secondly, then you look for the other side left. So that is what you have for that. Good. And when you do that, one of the side left even the side left, you can use Pythagoras theorem to get it. Like after getting, for here, after getting this and this, you can use Pythagoras theorem to get this one. Okay? Alright. So when you solve the other one, which is the B, the other side, which is the B, you get 44.77 centimeters. So write it so that you work towards it. And also, the angle, the B side is going to give you 56.68 degrees. 56.68 degrees. And the other angle to you get the other angle to, okay, you just find for only one of the angle and that is all, or you can continue to solve for the rest. Alright, so in our next video, we will be looking at angle of elevation or depression. See you.